Hi, and welcome to another episode of Raw Green, a show produced by Obi, your sustainability consultancy specializing in life cycle assessment, research, and green tech. Check us out at oneobi.com or connect with us on socials. Links are ready for you in the description. Ciiiao! I am Francesco De Lieto. I am passionate about sustainability and green technologies. Welcome back to a new episode of Raw Green. Today, we're talking about something that was in the airplane you flew on during your last holiday abroad. Something that's in that sporty car you own or dream of driving at all costs. Something found in the performance boats that I love. And something used in wind turbines to generate clean energy we all rely on. Today, we're talking about composite materials. Yay! Composite materials are everywhere, and rightfully so, I might add, as they are lightweight and incredibly strong. The problem? Every year, millions of tons of composite material waste ends up in landfills. That's billions of kilograms, if that helps you better visualize the scale of the issue. And why does this happen? Simple. They are extremely difficult to recycle. And current processes make the final recycled products too expensive, sometimes both, economically and environmentally. Our guest for today is Alessandro Stagni, CTO of Northern Light Composites, a kick-ass startup based in my beloved Italy that has developed composites designed to solve end-of-life issues. Their innovative materials are not only high performance, but also recyclable, meaning that they can be recovered and reused instead of piling up in landfills. Alessandro, welcome to Raw Green and thank you for being here. How are you on this day?
Ciao Francesco, thank you for having us here at Raw Green. I'm very good. I'm in Monfalcone, where we have our facilities, our production site, and I'm really happy and thrilled about talking about our startup to you.
Well, and we are happy to have you here. Why don't we start from the beginning? Okay, you are a technical guy. What are composite materials and where are they mostly used?
When we talk about composite materials, uh, we are talking about a very wide range of materials. However, the common sense when speaking of composites is about like um, polymer-based composite materials, so like carbon fiber or glass fiber composites. And they are used in many different applications, from the space shuttle to our bicycles, let's say. Um, they were born a long time ago, at the beginning of the 20th century, and they are used everywhere, really
Yeah.
everywhere.
So from a production and circularity angle, okay, what is the environmental problem with composite materials?
The main issues of composite materials, the one that are most used today, is lays in the kind of the matrix that they are using. Let's say the plastic phase, the polymer phase. In fact, most of composite, I would say that we can identify it as fiberglass, uses thermoset resin. Thermoset resin are a kind of polymers that is very versatile. It's super durable, has amazing mechanical properties, but it's really difficult to recycle. And this is a big issue because we cannot recycle the composite itself because of the resin that we are using in it. In terms of production technology, there are many different technology that are used today. the most used one are like pre-preg technology, vacuum infusion, in transfer molding, injection process, but they are all they all use thermoset polymers, as I was saying, and making the overall process very very versatile, but at the same time the material very difficult to be recycled once it comes to the end of its life.
What about one step, a few steps actually before the recycling stage? What about on the production side of these materials? Are they energy intensive? Are we talking about materials with a high carbon footprint? If you can please break it down a little bit, also from the production side.
Yes, sure. The impact of the production depends on the technology that we are using. So we can make a first big difference between technology that are called the autoclave technology and out of autoclave technologies. Autoclave technologies, that is the one using pre-preg composite, is the one that uses like a very is used when we need very high mechanical properties. For example, on airplane, F1 cars, space shuttle, this kind of technology. And they use high pressures, high temperatures to obtain very good mechanical properties. And pressures and temperatures, of course, comes with energy consumption, which means we have a higher footprint. On the other side, the out of autoclave technologies are carried on at room temperature with lower pressures, even let's say atmospheric pressure or just vacuum. And in this case, we have a much lower carbon footprint. However, the material used in the production of composites have a considerable footprint. Both the resins and the fibers during their production cycles have a considerable impact, and this is the reason why we really need to find a solution to make a circular economy for composite materials. For example, glass fiber energy consumption is about 45 megajoule per kilogram of fiber, with a carbon footprint of 1.5 kilogram of CO2 per kilogram of fiber. But this consumption is even higher for the polymer phase, where thermosets need above 80 megajoules per kilogram of polymer to be produced. And if we think about this is really important to find a solution to make this consumption as low as possible. Also, another big issue today is that polymers are obtained from petroleum-based compounds.
Yeah. Well, look, the integration of circular economy principles from the design phase of a new material, a new product, a new technology, whatever, it is actually at the base to think with that, let's say, life cycle methodology and approach in new designs. So why is it now? From the production, let's go to the recyclability of composite materials. Why are they so difficult to recycle? What is the issue in recycling composite materials?
The main issues lays in the chemical of the matrix of the polymer phase, which is mainly thermosets, and due to the chemical link between the molecules of the resin, this make the entire composite very difficult to recycle, because we need high temperatures in order to break this link and be able to separate the polymer phase from the fiber phase. Today there are some recycling technologies that are available on the market, let's
Like
say, that
thermolysis,
have
I've
been
read.
validated.
Yeah, I read about
Yes, there are
thermolysis,
like
pyrolysis. Yeah.
thermolysis, pyrolysis, mechanical recycling. There are also some studies for chemical recycling, but
Mm-hmm.
the main problem is that uh, they need high energy, they need chemicals, and they need huge infrastructure to be carried on an industrial scale.
So basically, there is a
And
chance that the recycled product coming from one of these technologies could have higher environmental impacts than a virgin one. Is that a correct assumption?
yes, today there is. It depends on the technology, but yes.
Mm-hmm.
For example, when we use high temperatures, we really need a lot of energy in order to recover the fibers, because we go above 500 degrees Celsius.
Mm-hmm.
If we want to contain the the energy consumption, we can go on mechanical recycling. That is just grinding down the material into very small pieces and use it as a filler. It's very commonly used for concrete and road building.
Mm-hmm.
But the main problem is that this the, the, this material, it's worthless. Let's say it has a very low value,
Value. Mm.
because we just break it down. So imagine of having a powder, you can do a very few stuff,
Mm.
which make it economically unsustainable. And this is even
Unattractive.
more true
Mm.
for thermal recycling, where we have to pay a lot of money to burn down the matrix, get back these fibers that are degraded, because the temperature degrade the mechanical properties. And so
Yeah.
again, we get a fiber that it's worth a lot less than the virgin one. And this is the
Mm-hmm.
reason why, even if we have the technology, it's not really applicable, and there is no interest into recycling composite material because of the economical side, of course.
Yeah, of course. Well, if the economics don't work, there is little incentive for people to invest into this kind, and also to procurement managers to buy these products, because that means that also the recycled product doesn't have that attractiveness from an economic standpoint, from a purchasing standpoint. So you briefly mentioned about the mechanical recycled product that has a very low value. Let's work on to the other alternatives. What are the usage on the other recycled composite materials, which, as you said, they lose some of their properties because of the high temperatures required to break down the matrix. But there are usage, I assume, for those kind of recycled composites. What are they?
If we think about pyrolysis, or in general thermal recycling, where we, let's say, burn down the matrix and we get back the fiber, we actually can get the fiber back as long as they were originally. So the application could be potentially the same, according to the fact that the mechanical properties are compliant with the requirement. So if I was producing an airplane with the carbon fiber, with a virgin carbon fiber, the recycled one, I don't, potentially doesn't have the same property as the virgin one, and so it can be used for the same application. We have to use it for a lower value application, but still it can be reused in the same way, let's say.
Okay, but still valuable. That's what you mean.
Yes.
What about costs? Is there like a big difference between buying virgin carbon fiber or recycled carbon fiber?
There is a big difference, yes. I mean, there is not a huge market for recycled fibers, as I was saying, because we don't have the facility to recycle it. So there are a lot of small producer, let's say, and this doesn't help in terms of having the best price, because the technology is not as scalable as for virgin fiber, and so the production costs have not the same benefit. So today there is a difference, but it's not as big as it should be. I would say.
Okay, it can be better. Okay,
It can be better. Yes.
What about composites made with natural materials, natural fibers, for example? I'm referring to flax. Do they have let's say the same durability? Do they have a better environmental footprint? And are they can they be put on the same level of let's say oil based or fossil based composite materials?
Yes, natural fibers are starting to be used quite a lot. There are a lot of application, and this is because the mechanical properties, if well treated, can be as good as glass fiber, with benefits in terms of weight reduction, because natural fiber are very light compared to glass fiber. So this is a very good point. But the real advantage in terms of environmental impact and circularity is that if we produce natural fibers in the correct way, we can obtain a negative environmental footprint.
Really?
And this is really important because if we think of generally the footprint is calculated as equivalent kilograms of CO2 emitted. And while for glass fiber or carbon fiber, we have a positive emission of CO2, so we need to produce CO2 to have glass fiber. With natural fibers, especially flax and hemp fiber that are the most commonly used, we can have a negative footprint. And this is because the plants, while are growing before in the field, they absorb more CO2 than the one needed to produce them later on. And this is very good for the environmental impact, of course. And also all the production waste, let's say, from fiber production, can be used for energy production, which means that there is a double advantage in this term. Yes.
Yeah. Well, no, I knew about hemp, that it is has fantastic carbon absorption rate. Really good. I didn't know about flax, to be honest. What about costs, though? Do they cost a fortune more compared to fiberglass and carbon fiber, or we're there parity, cost parity?
Yeah. Today, it's not really economical from this point of view, because the producers are few, volumes are low, and so again there is not this scalability in the production that contain the cost. For example, flex fiber cost almost as much as carbon fiber, but mechanical properties are not even comparable. I would say.
Yeah, I can imagine.
So from this point of view, it's not really sustainable on large scale production.
Okay.
However, the let's say the good point, even if it might not be that good, is that cost in composite production, the most of the cost in composite production lays in molds and workforce. So the raw materials cost is a small part, and even if like natural fiber are cost much more than glass fiber, which are direct competitors, it could be still valuable use flex fiber for this reason, because in the overall cost of production, this does not has not a big impact, I would say.
Why you say the mold? Don't you have to do it once and then you keep using it? Why is it the highest cost? Just out of curiosity.
Yes, I mean, you do it once, but it's really expensive to produce
Okay.
generally,
Okay.
because it's like producing this one piece. It has to be very precise. So
Mm-hmm.
usually is CNC machined, and there are a lot of machining to obtain a very smooth surface with a very tight precision, and
Okay.
this make it very expensive.
Okay. Okay. Good to know. Now, thank you for this brief masterclass on composites. Now let's talk about your stuff. Let's talk about what Northern Light Composites have developed. So, can you please give me an overview of what are they? What are the materials that you have developed? How they are done? And what are the both the environmental and economics data compared to what we just discussed about?
Yes, we at Northern Light, we we were born with the mission of finding a solution for the end of life of fiberglass. And over the past 5 years, we developed our own technology that we called our composite. And our composite is based on a thermoplastic resin system. That's the one produced by Arkema. That's our partner, the helium resin, which is a real game changer because, as I was saying before, traditional composites are based on thermosets. That is the real problem into the recycling cycle. And while in this case we are using thermoplastic, which it's much easier to recycle and makes all the composite recyclable. And what we did is to take this resin system and develop all the production cycle, all the technology in order to use it for the production of composite materials. And we were using all kind of reinforcement from the traditional one, glass fiber, carbon fiber, in order to make our technology comparable to traditional technologies, and also a lot of, let's say, new and more sustainable reinforcement, such as natural fiber. We work a lot with flex fiber, recycled carbon fiber, that's also very good for its mechanical properties, and cores that are again recycled and recyclable. The DNV certified our
Mm-hmm.
material for the recycled content and its recyclability process. So it's really a really good starting point, I would say.
Well done, guys. What about
Thank you.
though the properties, for example, durability? Now, the main difference about thermoplastic and thermoset, it is also that gives that, say, durable materials able to withstand. Think about offshore wind turbines, okay, which is an example that I always use. But offshore wind turbines, they have to spend 20, 25, 30 years in the middle of the harshest conditions. Salted water, UV lights, everything, winds, obviously. So are they able to match par on par the same performance of the others, or is it something that still will require some R&D?
Uh, since it's a new product, we don't have the same knowledge 40 years long as for thermosets. But from the test we have been carrying over these years, we didn't, and also the test that the producer carried by its own, we didn't see much difference in terms of durability.
Mm-hmm.
As you was saying, wind turbine blades have to last 20, 25 years. The time is this time frame is getting smaller, I would say, in the recent past, and this is because we want to improve the efficiency of wind turbine blades, and so they are keeping updated much faster in terms of aerodynamics and geometries, and so the lifespan is becoming smaller.
Mm-hmm.
The point is that actually traditional composite material are not lasting 25 years, they are lasting 80 years. We have boats since the 50s that
Yeah,
are
they're
still
still there.
usable. So
Yeah.
and this is the reason why it's really difficult to also recycle the material itself.
But now that you mentioned boats, there are some boats that retains their value so much. It is incredible. Thanks to the fiberglass, to the quality fiberglass that has been used. There are without doing some, brands naming, but a couple of Americans that they have of outstanding fiberglass, and you see the prices. Say you have 30, 40 years old both, and they are still more expensive than some of the new ones. It's absolutely incredible. You see the fiberglass is still there. It looks amazing. How resistant they are, but the application of composites, the usage and their durability, it is undeniable. The lightweight, the strength, the tensile strength, it is amazing. Well, for what you produce at Northern Light, what are the best and main applications?
Our main application is today is in the boat building.
Okay.
We're a group of guys all passionate about sailing, and we find it natural to start with building our own boat.
Okay.
We started with the Eco Racer. We already produced 2 units, and now we are starting with the production of the new model that will be an offshore racing sailing boat of about 10.5 meters. However, as we were saying all this time, composite material is a very transversal material used in many different applications. Yeah. And also our composite has the same this same peculiarity as traditional composite. So we are ranging in also different industrial application. We have a collaboration in the wind energy for producing vertical wind turbine blades with another Italian company. Nice. We already did some prototyping for electrical motorcycle for all the covers and detachable parts. We are working with other shipyards in order to make their product more sustainable, giving our technology to them. There is this big project that we have been doing last year with Cantiere del Pardo. That's a very big Italian shipyard.
Yeah.
Where they launched their new 10-meter day sailor, the Grand Soleil Blue, which is fully built with yes, it's amazing, and it's fully built with our air composite technology. So all
that's a big
fiberglass
project
today. Yeah. It was a very big project.
I love Grand Soleil. They're wonderful boats. So the next Grand Soleil is coming with the Northern Light composites, the hull and everything.
Yes.
Wow.
Yes.
Well done, guys. That's Cantiere del Pardo is a beautiful boatyard, beautiful production. The Grand Soleil, it is stunning. So That's a really nice project. Well done.
Yes, we are super proud about it. And also talking about durability and performance,
Hmm.
we are producing some parts, some components for the class 40 boats. Uh, that's boats meant to do transatlantic racing, sail racing, and we already did some parts for Ambrogio Beccaria two years ago, and it was super happy about it. And we are doing other components for another Italian sailor this year, and we are super happy about it as well.
I can imagine. I can imagine. Plus, in a very short time. So, well done. Let me ask you something else. What about competition? Do you have any competitors that, say, produce something similar to what you guys do, both in terms of environmental performance and also product performance itself?
In terms, I would say that the main competitors are other companies that are starting implementing this thermoplastic resin in their composites.
Hmm.
There are some over the Europe, but they are still, I would say, at a
Early
research
stage. Yeah,
research level.
very early
We
stage.
we we are uh, we, we were among the very first to start using this kind of resin on industrial scale.
Mm.
So from this point of view, I would say we are very well positioned in terms of competitivity. There are some other reality that are using, I would say, green composite in general.
Yeah,
If you
like the
look at
natural
for green
fibers.
composite,
Yeah, yeah.
yes, like natural fibers, bio-based resin. It's another
Hmm.
very important trend.
Yeah.
And this is it's really important because they are reducing the carbon footprint, of course,
Mm.
but the composite still is not recyclable. So
Oh, really? Okay.
if if I make a boat made out of flex fiber and bio-based epoxy resin, yes, I'm reducing the carbon footprint because I'm using natural fiber and bio-based resin, which is again, I would say, as a source as plants instead of petroleum, but it won't be easily recyclable. So again, we have the same problem as we have for fiberglass.
You know what? It just came into mind. I don't know if it exists, so I'm asking you to enlighten me. In energy production, you have the levelized cost of energy, which includes everything from the installation, the maintenance, and also the decommissioning of that power plant. I'm curious to know if there is something similar also for materials, where you have that levelized cost of materials that includes the production, the maintenance that you need to have. For example, boat hulls, you need to maintain them every X months or years, and also the end of life management. I'm curious if there is if it is a metric that it is already used or not. Because if it isn't, you and I have work to do immediately.
Uh, I would say no. I mean, there is like for energy sector because of the volume and there are a lot of big players. But for example, for the marine sector, we don't have the same approach, I would say.
Mm,
Um, in fact, this is the main problem for what we are not recycling uh, fiberglass hulls, for example, of boats,
yeah,
because the there is not the obligation for the dismissioning. You know, you are
yeah,
selling the
decommissioning.
boats to
Yeah,
a private person that can do whatever you want over its life,
yeah.
and then it's up to him to decommission it. But and this is the main problem into the recycling process, I would say.
Well,
You were
yes.
saying
But it's also a selling point, because if you factor in also the not just the production costs, but also, let's say, the maintenance part, the maintenance phase, the use phase. All right, we say, okay, thanks to my material, you're going to consume, I don't know, 5% less gas, 5% less energy in general, or you have to maintain it, instead of once a year, you can maintain it once every 5 years. Okay, and then at the end of life, if there was that, let's say, policy made in which there is also that responsibility at the end of life, likewise happens in energy production, that will make a massive difference in the overall pricing of the product. Again, when you keep in mind the whole circularity, from a whole circularity approach, if I make myself clear enough. So there isn't just upfront cost. That's what I mean to say. There is also a use and end of life cost embedded into anything, actually.
Yeah. Yes. You're right. The problem is that today I'm talking about the boat building because it's the one I'm more confident about. Mm-hmm. And today there is no regulations that like oblige the producer to be in charge also of the end of life of the component. While for example, for cars, the car producer have to design cars in order to be easily recycled, easily disassembled, in order to make them as circular as possible. This is not true for fiberglass, I would say, and for boat building. In fact, as you were saying before, that there are a lot of boats retaining price over the years because they are really durable, they are amazing. There are much more boats that are worthless, but kept running just because people are like giving it for free, because otherwise they should be in charge of the end of life management. Which means paying a lot of money in order to throw the boat away. There is a rough estimation for dismantling a boat that's like 1,000 euros per meter. There are many times they are just giving it for free, and there are like young people very passionate that will take it, do some maintenance and start sailing, or they just forgot to have the boat into some yards, and it became a waste over there. And this is a huge problem, especially for the marine industry, I would say.
What's next for Northern Light Composite? What's a big project or new technology you're working on?
Next big project is in the short period is the building of these new 10-meter boats. It's a really challenging project, and we're super happy about it. The mold just came into the yard, so we are really starting the production in these days.
Fun time.
And and we are starting to implement different production technology. Today we are working with the vacuum infusion, but we are willing to introduce also light RTM in order to be more flexible on the production, to be more scalable. And this is another big step forward. We are keep working on finding and creating a very big, I would say, chain of value of suppliers that provide recyclable raw material. This is another important point. And then, of course, we are working with other companies developing recycling technology in order to start implementing it also on small scales, such as our shipyard, and keep and start to optimize the recycling process for composite in order to make it as sustainable as possible and to retain as much as possible the value of the raw material that we are recycling.
Very good. Very good. Well, thank you, Alessandro. This was very, very interesting. Lots of things learned for sure, and lots of positive and productive hope for the future. I mean, the reusability of the materials, it is definitely a milestone, an important milestone across different industries. So well done to you and your colleagues and at Northern Light Composite. And I look forward so much to see that Grand Soleil, so very much. So go crack that mold, and I'll talk to you soon. Thank you for being here.
Thank you, Francesco.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and the green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciiiao!